For the introduction, a first-order differential equation is an equation that contains only first derivative, and it has many applications that can be used, like in mathematics, physics, engineering, and many other subjects. In some of the applications that commonly used are in mathematics. Also, a first-order differential equation plays a vital role in physics that includes a temperature problem which requires the use of Newton's law of cooling of a particular substance. In mathematician history, differential equation were began known in 1675 when Gottfried Wilhelm von Leibniz wrote the equation known as below. The research for general matter differential equation is an equation that involves one or more derivative of differential that any equation. It is also defined as an equation containing the derivative or differentials of one or more dependent variables with respect to one more independent variable. The existence of differential equation is very useful to the world, like in the mathematical modeling of physical system. Law of physics and chemistry can be formulated as differential equation. Differential equation is classified according to three properties, which include classification by type, classification by order and degree, classification as linear or non-linear differential equation. Solution of differential equation. The first order differential equation has variety of methods in finding the solution of equation, like variable separable, equation reducible to variable separable, homogeneous equation, first order exact differential equation, and linear equation.
My name is Muhammad Amirul Naim bin Hakimi and I will continue with the Pbl table. Our group had choose question number 3 for part A. Here are the questions. Pbl table for part A. The fact is, first, in year 2000, a small city had 310,000 people. Number 2, a small city has grown at a proportional to its size. 3. In year 2005, the population increased to 400,000 people. The is first, solving the problem using population growth model equation. Second, solve the problem by using the formula Pt equal to Po exponent Kt. Learning issues are finding a formula for the population of the city 3 years after the year 2000. Second, calculating the city's population in the year 2010. 3. When will the town reach a population of 1 million people, assuming the current rate of growth continues? For the resources needed, first, internet. Second, we use engineering mathematics slides. Third, we use engineering mathematics video. And last but not least, we use calculator. For part B, our group choose question number 3. Here are the questions. For part B. Facts. The equation to solve the problem is dv over dt is equal to negative kb to the power of 2. Second, k is constant. Third, the initial velocity of a moving object in water is 40 m per second. Fourth, the velocity drops to 30 meters per second after 2 seconds. For the ideas, first, making use of the first order differential equation or first ODE equation. Second, using population growth, find the general solution to the problem. In issues, first, determine the equation's general solution. Second, determine the velocity solution after 10 seconds. And last but not least, complete the equation correctly. For the resources needed, we use internet, Engineering Mathematics 2 slides, Engineering Mathematics videos, group discussion, and last but not least, calculator. The minutes of meeting for our groups. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Khairi bin Abdul Aziz. My number metric AA 200226. So today I will present about solution part A. Okay, we start with a question. PT bersamaan dengan PO eksponen KT. Itu formula untuk populasi. So pada tahun 2000 populasinya 0.3 million pada tahun 2000 dan pada tahun 2005 populasinya sebanyak 400,000. Jadi kita ambil T0 T0 bersamaan 0.3 million dan T5 bersamaan 0.4 million. Jadi kita masukkan PT 0.4 million equal to PO 0.3 million, K dan T kita masukkan 5. So eksponen K5 bersamaan dengan 0.4 dengan 0.5 million. So kita akan dapat di situ, kita akan masukkan in, kita akan hapuskan eksponen kat situ dan kita akan dapat K equal to 0.0575 constant. Pada setiap tahun dia akan meningkat, kadarnya akan meningkat 0.0575. So seterusnya soalan yang telah diberi, kita akan we want to find P when T equal to 10. So P equal to 0.3 million eksponen eksponen 0.0575 darat dengan 10. So P kita akan dapat 0.533139 million, di mana P populasinya pada tahun 2010 sebanyak 533,139. So soalan seterusnya kita pergi di mana soalan seterusnya mencari masa apabila populasi manusia sebanyak 1 juta. So 1 million equal to 0.3 million eksponen 0.0575 T. So eksponen 0.0575 T equal to 1 per dengan 0.3 dan kita akan masukkan in untuk hapuskan eksponen. Jadi T equal to in 1 per 3 1 per 0.3 bahagi dengan 0.0575 dan T kita akan dapat 20.93, di mana kita bundal akan menjadi 21 tahun. So pada tahun 2000 kita akan tambah sebanyak 21 tahun lagi dan akan menjadi tahun 2021 populasi kita akan mencapai sebanyak 1 juta. Sekian, terima kasih daripada saya.
Okay, so now it's my turn to explain about part B, question 3. So, okay, basically there are two problems to solve in this question. The first problem is we need to determine the equation to the general solution. Okay, so we need to separate the equation, and it is shown as dv over dt equal to negative kv square, and integrate them into dv over v square equal to negative k integrate dt. Then integrate the ln to the equation, and it turns to ln v equal to negative kt plus c, and then after that it becomes v equal to exponent the power of negative kt plus c, and then we also can separate the exponent into exponent power of negative kt and exponent to the power of c, as we know, where a equal to exponent power of c. So on the right hand side it becomes v equal to a exponent to the power of negative kt. Then we get the general solution equation. Okay, after that the second problem is we need to determine the velocity of fluid after the 10 seconds. So the first thing we need to do is determine the equation of decay, which is n bracket of t equal to n0 exponent to the power of negative kt. Then the second thing we need to do is substitute the initial rate of velocity, which is t equals to 40 meter per second, and n, which is the dividation between 30 and 40 meter per second into the equation, and it becomes 0.75 meter per second. Substitute and it becomes 0.75 equals to exponent to the power of negative 40k. So after integrate the k will come, and it is k equals to negative 7.192 times 10 to the power of negative 3. And lastly, we need to find the value of t by using the same equation, but substitute the k value into the equation. So we calculate and we can get the t value, which is equal to 0.00004 meter per second. You can see in the question said there is a question of velocity of an object moving through a fluid can be modeled. Then we need to find the answer for this question. So in this question we need to use the several equations that can solve and convert to general equation. And after that we need to integrate the definition into the answer come out, which is the decay equation. And the bracket of t equals to n0 exponent to the power of negative kt. After that, the question say we need to find the velocity of liquid after the 10 seconds. So to find this, we need the initial velocity, which is t equals to 40 meter per second. So then we substitute the equation and we calculate, and we come up 0.004 meter per second. So you can see after 10 seconds the velocity of water almost to 0. Thank you.